This video will be about limits involving infinity. So the first thing we'll talk about is where we're taking the limit at a constant number and we get infinity as the answer. So this would be something like the limit as x approaches c, where c is a constant, of f of x, and as our answer we either get infinity or negative infinity. And any c where this happens, we would say that the line x equals c is a vertical asymptote of the function. So let's look at an example where the limit is positive infinity. If we think about our function, let's say we have 1 over x squared. We can examine the graph of this, and we see that it looks something like this. And when we get close to 0, we can see something strange happening, in that things are going off towards positive infinity, it seems. So in this case, we would say that the limit as x approaches 0 of our function equals positive infinity. And then we can say that 0 is a vertical asymptote. The case where the limit is negative infinity is very similar. So here we can think about the graph of f of x and let that simply equal negative 1 over x squared. That means that we have a graph that looks something like this. So it's the same as the graph of 1 over x squared, except flipped over the x-axis. And so again, we have a vertical asymptote at x equals 0, and we have that the limit as x approaches 0 of our function equals negative infinity. In some cases, at a vertical asymptote, the function will approach negative infinity coming from one direction and positive infinity coming from another direction. Let's take, for example, the function 1 over x minus 3. The graph of this has an asymptote at x equals 3, and the graph looks something like this. So you can see that as we're approaching 3 from this side, it goes towards negative infinity, and as we approach from the opposite side, it goes towards positive infinity. In these sorts of cases, because the limits from the right and the left are not the same, you would say that the limit does not exist. So we've been talking about vertical asymptotes, but how do we find them? Let's say that we have a rational function, f of x equals g of x over h of x. Then the line x equals c is a vertical asymptote if h of c equals 0 and g of c does not equal 0. If it happens that h of c and g of c are both 0, then instead of a vertical asymptote, we usually have a hole. So when trying to find vertical asymptotes, we have to be very careful to check both the numerator and the denominator.